Yeah, good day everyone. You're welcome to my YouTube channel. Um, it's been a while actually. I've been busy with some designs and I've been busy with work. Um, this I mean, there's something that I've noticed is that majority I've been watching videos and I've been seeing our content, but they have not been subscribing to the channel. Please kindly subscribe to the YouTube channel. So when we drop nice and wonderful videos like this, you get a notification, and it helps YouTube to also publish the content to other people that would be interested in it. So for today, we are going to design a simply supported beam and a continuous beam. We'll be using STAAD. So I will design a complete structure with STAAD. Yeah, I will design the slab, the beam, and the columns with STAAD. But today I just want to show you guys how to design a simply supported beam and a continuous beam using the software STAAD. So um I want you to pay close attention to this. So let's take example from a textbook. Then we'll now compare the analysis result of what we got to what the textbook actually gave us. So let's go. Let's use this textbook. Let's use this textbook. Okay. So we'll be doing two examples. We'll do one simply supported and one continuous. We'll do one simply supported and one continuous. So now let's design this. Yeah, let's design this. Um, this one is a simply supported beam. So we have a span of 4.2 meters and we have a UDL of 20.5 kilonewton per meter. Okay, so let's design this first. Let's compare the result of the moment. Then from there also we can now design this one that is a continuous beam. So let's work on this first. Let's work on this first. So let's start. Let's start now. Um let's go to start. So let's create a new project. Let's call this start beams. Yeah, let's call this start beams. Yeah. So let's click on next. Add beam, finish. Okay. So it's up now. Then if you want to model anything on Start Pro, it's advisable you model it on the exit plane because the structure is actually in an exit plane. When we want to design a full building structure, maybe a two-story building or a one-story building. I haven't decided yet. You see what I'm talking about. So we go to exit plane, right? So we have an exit plane. Then we click on OK, right? So then the next thing we need to do now is to look at what we actually want to do, which is the span is 4.2 meters. 4.2 meters. So let's go. The span is 4.2 meters. Let me bring it back. Come, let me delete this. Let me delete this. Okay. So let's bring this back. So let's go from 0 to 4. Let's click on escape. Then let's take this off, right? So this is 4 meters, but remember that it is actually 4.2 meters. So we can move this, extend this. So let's move it the X plane by zero point 0.2. Then we'll click on OK. Then we'll click on yes. So let's confirm the measurement of what we've done here. So let's click on this. So we have 4.2 meters, right? So let's check what we have in the textbook. It's actually 4.2 meters. So it's 4.2 meters. Okay. Then we have a UDL of Okay, let's put the support first. We have a support. So you go to general, then you click on support, then you create support. Now the support is pinned. So click on pin support, then we add this, right? Then press Shift K, then you add this, right? Then let me take this off, this measurement off. So if you press Shift K on your keyboard, it actually brings out the note. Okay, so let's go to support now. Let's click on support. Then let's add the support to it. So let's bring this and let's bring this. Then we'll click on assign to view, assign, right? Let me put it in the plan view. Okay, so the support has been assigned. So the next thing we need to do now is for us to assign the property to it. Now let's check what the textbook provided. Is it a 230 by 450 beam? Said a roof beam, blah blah. It to be okay, 230 by 450. So let's assign a property of 230 by 450 to the beam. So okay, so let's go to property. Let's go to property. Then let's go to um define, right? Then let's go to rectangle. So the YD is the width. So you have 0.23. No, you have 0.45 rather. Then the ZD, the YD is the depth, while the ZD is the width. Then you have what? 0.23, right? Then we click on add, right? So we can assign this now. So click on assign, assign to view, assigned already. So this has been assigned. The next thing for us to do is to load, is to actually load. So let's check what the load is. The textbook. So it's having a UDL of 20.5 kilonewton per meter, right? So let's go. Okay, so let's go to load definition, load cases, then let's add, right? Let's add this. So we have, so let's call this beam load one. Let's call this beam load one, right? Let's add, right? So let's create the load. So you go to member load. So you have minus 20.5, right? Ensure that it's on the global y coordinate. Then add, right? So we can add this now. So we have assign to view, assign to selected beam rather, assign. So let's check this. Let's go to isometric view. So let's check the value of the load if what was assigned is correct. So you just right click, you go to label, then you click on load value, you apply, then you say okay. You see, okay. So this one has been sorted out. So the next thing we need to do now is to, okay. So this one has been sorted out. So the next thing we need to do now is to create the second is to create the second beam, right? So let's bring this out. Okay, let's bring this out now, right? So let's put a node there. Then let's click on escape. Then let's take this back. So we have a node here, right? So let's do translational repeat. So let's go to translational repeat. So we have, let's check how many do we have. So let's count. So how many spans of beam do we have? So the first one is what? The first one is we have 1, 2, 3, 4. So we have 4 spans of beam. So let's go back to our start. So we have 4, right? We have 4. So let's click on link steps. So the first one is 4.2. We have 4.2, 4.5, 4.2, 4. So we have 4.2. We have 4.2, 4.5. We have 4.5. Then we have 4.2, right? So let's click on. So let's confirm. Let's confirm. So okay, so we are correct. So let's go back to start. Then we click on okay. Can you see? Okay, so this is what we have. So let's add a support to it. So let's go back to plan view and let's add support to it. Let's go to the support. So we have a support. So let's add assign to selected assign. Okay. So this is what we have. So let's now apply the load to this, right? So let's go to load. Okay, sorry, let's apply the property to it. So let's go to general, let's go to property, right? So let's click on this, start to selected beams, assign. Okay, so we have this. Okay, so the next thing we need to do now is that we need to create a load for this now. So let's go to load cases, let's add. So let's say this one is beam load 2, beam load 2. So let's add this, right? So let's add the load of this one. So the load is, so to member load. So the load is what? Minus 57, right? So let's add and let's close. So let's assign to this. So assign to selected beam, assign. You can see, right? Okay. So let's check. Okay, right. So very good, very good. Okay. So the next thing we need to do now is to run the analysis and see the values of what we are going to be getting. Okay. So let's go to general now. Let's see what we have. Okay. So let me see the properties. This has been assigned. Okay, very good. So now the next thing we need to do now is to run the analysis now, right? So the first thing we need to do is to go to what? Analysis and print, right? So let's add this. So we actually need to perform the analysis. Then let's go to design. Let's go to design. So concrete, right? Is on concrete. Okay. So um so let's define the parameters already. So this one, okay, so I want a concrete cover um of 25 millimeter, right? The main reinforcement should be, okay, let's see, 4100, right? Let's add that, right? Although I'm only interested in the bending moment and the shear force diagram. I'm not really interested in the, okay, but no problem. Let's just, then you have 20,000, right? So let's click on add. Let's close it. So let's define command. Since it's a beam, I'm only interested in the beam. So let's add. Okay. So let's now assign this now. Let's assign this. So let's assign to view. Assign to view. Assign. Or let me just copy everything. Assign to selected beams. Assign. Right. Assign to selected beams. Assign. Let me design the beams also. Assign to selected beams. Assign. Okay. So let's. I haven't done that of the cover. So 0.025, right? 0.025. So we add, right? Okay. So let's assign to selected. So let's copy this. Assign to selected beams. Assign. Very good. So let's perform the analysis now. So we'll go to analyze. I will click on run analysis. Okay. So let's wait for it to come up. Okay. So let's go to the post processing. Let's go to the post processing. Yes. I want to use the tool load. Okay. So let's click on the MZ. Let's click on the MZ. Okay, which is that of the bending moment, right? Then let's go to result, view values. So I want this, I want this, I also want this. Annotate. Okay. So let's compare and contrast the values of what we got. the values of what we got. So this one is what 45.202. So let's check the textbook and let's see the result of what they got for their bending moment diagram for this, which is what 45.202, right? So we have this to be what 45 point. Okay, where is it? Where is it? Okay, yeah, you can see the value of the moment. Design ultimate moment 45.20 kilonewton meter. So let's check let's check the value of what we got also. So also got 45.20. Okay, so let's go for this now. So let's go for this. Let's go for this. Okay. So let's run the analysis again. Let's run the analysis again. Okay. So let's go to post processing, right? So okay, okay. So let's go to post processing and let's see what we have. So this one has been calculated already. Okay. So okay. So let's run the analysis again, so we can view the result for that of Limlo 2, right? For that of this one. This one. So let's run. I mean, we've already seen this, and we saw that it was still the same 45.202 as in the textbook. So let's run the analysis again. So let's go to analyze and run analysis. So let's wait for it to come up. Let's wait for it to come up. Then let's go to post processing. Yeah. So we just want the value for that of beam load 2, right? So let's click on this, apply, okay, right? So let's check what we have for this. Let's see what we have for this. So let's go to okay, let's click on the bending moment, which is MZ. Then let's go to result. Let's go to result and let's see view value, beam result. So let's click, and let's annotate, right? So let's confirm what we have with what we have in the textbook, right? So let's confirm what we have with what we have in the textbook. Okay, so let's see. So we have 69.731 here for the sagging moment. So let's check this. Let's check this. We have okay. So we have 69.43. Okay, almost the same thing. So let's go back to start and let's see what we have. So we have a log moment of 111.909. So let's check the textbook. Let's see what we have. We have approximately 112.525. Okay, the same thing. So let's check also. We have let's see what we have again. We have 44.083 sagging moment. Let's see. We have 44.01. Okay. So let's check again. Let's see what we have. So we have 88.488. Let's check this again. Let's see what we have. We have 88.015. Okay. So let's check again. Let's see. So we have 1169. So you see that is actually almost the same thing with what we have in the textbook. So thank you very much and see you in the next class. Thank you.